welcome to this episode of Conscious Design. I'm your host, Ian Peterman, and author of the Conscious Design book. And I'm excited today to be talking to Sadek and Adam. We're going to be talking about their novel method of rammed earth construction, which they're calling Selective Earth Forming. It's going to change, I believe, how rammed earth is able to be used, and very exciting. So welcome to the show.
Thank you. Hello.
Yeah, so everybody loves a good origin story. Can you talk a little bit how you got into this project and this research and what drove you to go, let's figure out another way to do rammed earth?
Yeah,
sure.
Well, we met at university in when did we start?
This was
2021.
21. Yeah.
2021. Yes, there you go. And it was for a master's degree project, and it was our final project. And myself and Sadek and our other friends, Jar, who can't be here today, unfortunately, but we were grouped together, and because we were all showing quite some interest at the time. And the course in general was kind of looking into ceramics in economic and architectural setting, architectural ceramics. And so we had this whole base of research that we were kind of trawling through, and we kind of took a step back and we were like, okay, what about not ceramics, what about clay? Let's have a look at clay. And we started this kind of second branch of research, which kind of led us into, which showed us all about earth building and how, clay is this really, really powerful binder.
There was one key, sorry, I'm just going to interject. We were looking at ceramics, and I think we were looking at wall tiles, and there's this architect, Martin Rauch, who is really famous in rammed earth. But what Martin did was he used wall tiles sort of horizontally and put them into the rammed earth. So what they would do is mitigate rain erosion. So I think we kind of looked at these tiles and we were like, well, we didn't have a kiln big enough. And I think that was also an issue in the university. So we were thinking, how do we do a project without using a kiln? So rammed earth was like perfect. And we all looked at each other and we're like, yeah, we're all going to do rammed earth.
This is it. We put this book down on the table in front of us and we're like, yeah, this is it.
Yeah, I remember it was in the university canteen. And I think that's when we were like, yeah, this is going to be a good project, and it all started from there. And
So obviously you went from there, and can you talk a little bit about your process and thinking, because you're approaching rammed earth from quite a different perspective, and for people listening, I guess typical rammed earth is just what you think it is. It's rammed earth. You compress it, use some boards. And today we talked about this a little bit, and part of what intrigued me with your project is you're able to do shapes that aren't just some 2x4 put together to block off rammed earth. You talk about that, your process that you've come to now.
Yeah, so go now.
No, go on, sir. Go
on. So yeah, traditional rammed earth is basically like you explained, it's very basic. You work vertically, and the idea is that you have two walls, usually out of timber, and those dictate the final geometry of the wall. And you kind of build vertically, so you end up with very standard sort of 90 degrees walls usually. And we didn't initially want to look at the we didn't know what we were going to end up with, basically. So we started off looking at all the traditional methods, understanding how the material works, what the materials are, and really getting to know what rammed earth is. So after we did that, we kind of understood that you need clay, you need sand, you need earth, and then water to hydrate the mix.
Yeah, I was gonna say, because originally, we started by just doing it and getting like a physical understanding of how it all works, and originally a strong part of us was like, the arrangement of aggregates within the wall, and how kind of different densities and different sizes can help mitigate erosion. There's already a massive body of research around, but like how we can more accurately kind of place or locate these aggregates within the wall. But then as we were doing it, we were like, actually, there's another huge great limitation here of like we're literally just building these very linear, very straight walls. You can get a little bit of curvature in there if you really want to, but it's not a very easy process. And so we actually realized that there was a union here between these kind of geometry problems we were having and the aggregate placement, because we were experimenting with different aggregates and different kind of ratios of kind of sand and stones to clay. And sometimes we were getting some terrible results and the fact that the stuff just wasn't binding at all. But then that actually turned into what would become our selective earth forming process. And like another link that we made was, as we were going, obviously rammed earth, building up in layers. Depending on the kind of process you decide on. I think we did 100 mil layers compressed down to 50 mil every time. And we were looking at this and we go, actually, what's very similar is 3D printing, build up in layers. And we're like, here we're building up in layers, but we're doing exactly the same profile every time. And we were like, what if, like 3D printing, we build up in these layers, but as we go up, we vary this profile and we vary this contour to make different, to create these 3D forms. And so instead of, we switched from doing kind of a linear wall and we made our formwork into more of a build volume. So we expanded it widthways and shrunk it a little bit lengthways. So we actually had this, I can't remember what the size we settled on. I think we did 800 by 0.8 meters, 0.8 by 1.2 meters. What big, I think. And then with a theoretically sort of infinite height, I guess, because of the way we built up our formwork. And I'll finish off this train of thought. So we ended up building this nozzle, this robotic deposition canister, I guess, which would deposit this non-binding mix into the profile that we wanted to create on each layer. And that would leave all these voids that we would then fill with a binding mix. We'd repeat this every single layer, and this robotic head would vary the profile every single time. And then once we were finished, we'd demold. And where the non-binding mix had sort of created these very intentional fault lines in the material, we'd have these big off-cut blocks which we would pull away, and then we'd be left with sort of our desired geometry left behind in the inside. And so we had to sort of create this quite nice, quite powerful sort of prefabrication workflow for unique geometries in rammed earth. It's a really great moment.
That's awesome. And so you're still ramming the earth? You're still adding pressure, so it's a deposit press process then? Is that accurate?
Yes. Yeah.
Got it.
So I think I guess we did add an extra step to it, which sort of does make it longer. But I mean, we were still ramming by hand as well. I think we're still working on a little bit. Always, exactly. But I think thinking about the future, I think as we're adding this sort of automatic deposition process anyway, I think the next step would be to add an automatic ramming process as well, and kind of creating that kind of workflow.
Yeah, so it's very like 3D printing. You just figured out how to do a non-binding, the filler material to fill the space in that you're able to do. So did you play with shapes like being able to do an arch and have rammed earth and be able to hold? Is it kind of how much can you do with it while retaining structural integrity to that, that level?
So we did for the final project, what we did was we created a doubly curved wall, and it had a bit of an overhang. And this wall, it was a section of a wall. I think it was about 2 meters high and maybe like half a meter by half a meter thick. So that was quite impressive. I think the next step would be to see what else we can achieve, what are the geometries we can achieve with this. And some of the things that we're looking at are undercuts, cavities inside sort of bodies. What else? Can you think of anything else? I know there was two
We
more.
did. Yeah. Well, I was going to say we did also do some smaller scale arches, which were promising, but with the deadline cut, we weren't 100% confident that it was going to work on a large scale. So we took a slightly more friendly option. But
You
yeah,
gotta take
no, yeah.
steps.
So exactly, little steps, and yeah, so yeah, channels, yeah, undercuts, channels through the material for things like surface access, like pipes and wiring potentially. And then I think also we talked about surface textures, which could dictate erosion patterns and things like that. And
Yeah, actually, that's a good point.
Yeah.
So when we were sort of doing this selective earth forming and testing it out, what we realized is the actual deposition of the material creates a sort of cone throughout, and then what you end up with is these beautiful ridges. So it kind of had its own signature look.
Okay.
But you could kind of identify it was selective earth forming through the ridges, and that was pretty impressive. But we would want to sort of explore if that's beneficial in any way, or if not, how can we minimize that in the future sort of iteration of the device. But it was quite exciting because we were like, oh wow, it's actually it looks beautiful. It looks like natural erosion, and it's actually this very technical, very sort of digitally led process.
And it was also like a very still quite a workable surface as well. So you could leave it raw and let the weather do the sort of final finishing, I guess. Or you could just very easily take in any kind of. I mean, we just ended up using 2x4, so like just scrape it, because these little fins that it leaves are like a little bit weaker. So just scraping away until you get like a nice smooth surface, which you can finish as well. But we got kind of mixed responses on that. Like some people loved it, some people were like, oh, do you think you can make it smoother? And so I think we can do both.
I feel like that happens with everything, even like 3D printing. Some people are like, "Oh, this is really cool," and others are like, "It's not smooth. I would like it. Make it polished, please." Can you?
Hey, it's Ian here. So glad you're enjoying this episode of Conscious Design. If you want the full scoop on conscious design, what it is, how we do it, how you can do it, then check out our book. We wrote it so creative entrepreneurs like you can code social and environmental responsibility right into your brand's DNA. You can download the first chapter for free. Link is in the description. Enjoy the rest of the episode. Don't forget to like, subscribe, and share.
Well, that's awesome though. It's gives it its own look. I love the fact that it kind of is this identifiable, if you want it to look the way it comes out of the mold, basically, you can do that. And if people want to polish it, they can always pay a construction worker extra to go polish everything for them. Exactly. So they can do that. I really like the idea because I've talked to some people about like rammed earth and other eco-friendly building and construction processes, and not all of them are very friendly to things like wiring. And that's there's a group of people that are like, oh, I want to build a house and no electronics would be in the woods. Like, okay, that's cool. And we have the rest of the population that still wants to have Wi-Fi and running water and all these things in walls. And so this is a unique. Rammed earth isn't exactly easy to do that. You kind of have to mount things outside of the wall and then cover it up. And it's almost like you're more building a stick house inside of rammed earth rather than constructing everything with that. So I think it's really promising that you guys are being able to do this because it's going to allow an architect to do more with it, and it won't be as limiting, which is for me exciting. If you can't make it look good, then mass adoption is not going to happen. So
Exactly.
being able to combine those functions, you can put pipes and things in there and it doesn't fall apart, and having this be able to cosmetically change it as well is something that I think is going to be really beneficial. What kind of, I think you mentioned when we chatted before, Sadek, but have you had any reception from architects? Kind of who's looking at what you guys are doing, and what's kind of growing from there, or inputting to you of how you might work on and adjust your process?
Yeah, we did actually have some sort of engagement with our final piece, and there was some attraction to the process. I think we had an architect who actually approached Adam just by chance, and they were looking at creating a curved rammed earth structure. But the problem is that timber prices have gone up. So so actually creating this this sort of structure out of rammed earth would have cost them a lot if they had gone with the conventional method of using timber formwork. So it's really funny that this person came up and they were like, I want to do rammed earth, but actually it's going to cost me a lot. And they're like, we've got the solution. So that was really funny. But actually they ended up going with a different method just because I think we're still quite early. We need to develop this method a bit more before it can go commercial. But what we want to do is expose this a bit more and kind of show the world what selective earth forming is. And I'm pretty hopeful that I think a lot of people will see it and come to us and sort of say, oh, I've got this problem, but you've got the solution.
Right. Well, and how are you able to be cheaper? Because that's also, I mean, the other way to win people over, right, is to be like, well, it's also cheaper. So why would you do a worse process that's more expensive?
We don't actually, so we only have one standard timber formwork. And then because we're able to sort of create any geometry within that, it means that you don't need to create another sort of timber formwork for those curves for whatever geometry you want, which is what you typically do with rammed earth. So you're actually minimizing a lot of one-off material wastage.
Got it. So you're more, I guess if I were to describe it, kind of be like sand casting metal, where the box doesn't change, but the sand inside of it does. You're able to reuse that same frame as many times as you want, because the sand part is what you're actually customizing every single time. So you're able to never waste sections and just keep reusing that.
Exactly. Well,
and
we just sort of brush it off.
I think.
Go on.
Sorry. I was gonna say that, like, I think so what we realize is that actually, like, the ideal kind of union isn't to have an entire house built using selective earth forming, but it's to kind of use conventionally rammed earth formworks where you do need it, that straight wall, you know, when you need that, use it. But then at like these occasional points where you do just need these very subtle changes, or even quite dramatic features, you know, then this process is here, ready to go, ready to use. And yeah, I think that's sort of how we sort of saw it fitting in nicely to the existing processes.
Got it. Are you thinking in that process that because you talked about building automation and getting into that side of things, are you thinking of something where you can choose to have it, you know, do your process, or regulate basically one machine that does it all? Like, how are you thinking of that process working?
Not entirely sure. Yeah,
I think thing we're really keen for is still to be able to keep that. One of the really great things about rammed earth is that it's really, really accessible as a process.
Okay. That is true. Just need some dirt and some plywood. So that's awesome. Well, what are you guys looking kind of down the road? What are you guys looking, if you had any specific, input that you're aiming for? Is there any kind of, where do you see this technology and project going?
Yeah, I think now our next steps is, like I said, sort of looking at all the possible geometries achievable with this process. And maybe we'll work a bit small scale for that stage. But we also want to create another iteration of the device. So we've already got a gantry sort of system. So it sort of works in an XY axis. And and it kind of deposits the material, but there was a lot of manual sort of tasks involved within that. So we do want to automate a lot of that. And I think what would be ideal is if we could sort of partner with someone who has those sort of tools that we can integrate into our process. So ideally, I think for this to actually happen, we need people who are interested in rammed earth to actually come to sort of want to develop this with us. So if they've got a project, then we can kind of work on with them. And I think that would help out a lot.
Yeah. Are you guys are based in the UK? I live in Tucson, where rammed earth is pretty popular. Everything we talked about, Arizona in general actually is pretty popular. How popularity wise, is it something that in the UK is big, or are you gonna have to look outside of the UK to be able to do this kind of, what does that look like for you guys?
The rammed earth scene in the UK is still a little sparse. It's not the most trusted, I guess, of materials. But even in Europe, like there's been a massive, even like over the last 20 years or so, there's been a massive resurgence in the rammed earth structures, which is sort of proving that it can survive in quite more temperate climates, and it's slowly trickling into the UK construction industry. But so hopefully there's a wave to ride there, I think, in the UK. But also it would be amazing to do rammed earth anyway, I guess. Yeah.
Awesome. Well, before we kind of wrap up, is there anything else you guys want to share or talk about? The technology, what you guys are doing?
I don't know. Not sure. Is there anything else that you'd like to know?
No, I think you guys it's not a extremely complicated technology. You're just really combining some things that people are like never thought of, which is great. I think that's like those kinds of steps are perfect where you guys go, hey, look, this isn't super complicated, so it's not going to be super expensive to do, or it's not like it's 10 times the cost or something. So yeah, I think you guys have described it really well, and I'm excited to see where it goes. I hope that this really takes off and we can help. Maybe we'll be able to help rammed earth become more popular, because it won't just be 4 straight, perfectly perpendicular walls, and that's all. That's all you get.
Definitely.
Yeah,
definitely. That was one of the things that we hoped would come from it, indeed.
Yeah, I think also just looking at sort of waste streams in construction, when we were doing our project, it was actually really hard to source earth locally, and we ended up having to purchase it, or I think we got clay from somewhere in south of England, and then some of the materials from somewhere else. But point being that we actually had a lot of these materials quite close to us, and a lot of these construction companies just didn't want to talk to us, and it was just too much hassle for them to actually deal with giving this material to us, rather than I don't know what they do, like pay someone to dispose of it. So I
Yeah.
really hope that like these kind of projects like ours, and I think there's a few more who which are looking at earth materials, that they do actually become a bit more popular, and there is a bit more demand for these very local materials rather than sort of importing whatever materials they are.
Yeah, that's a good point, right? If you're building, you are building on dirt at some point, so it's a much more local resource. And if there's huge excavations somewhere, being able to use that to build a structure would be very economical and eco-friendly as well, right? It's not, you have to ship it in from somewhere. So
Exactly.
awesome. Well, for anybody that wants to get a hold of you guys, talk about your projects, learn more, kind of what's going to be the best way for people to find you, either social media, website, whatever you guys have.
I can give my Instagram maybe. That's
Perfect.
usually what I use. Um, yeah, so my Instagram, I don't know off my heart. Yeah, it's sadek.dwg, so sadek.dwg.
Perfect.
And the best way is just to probably find me on LinkedIn. That's Adam Meyrick. That's Meyrick.
Perfect. Well, we'll make sure those are in the description too for everyone listening. You can check those out. And yeah, I really appreciate both of you taking some time to talk about what you guys are working on, and hopefully we see this take off for you guys. It'd be great to see this actually going into some construction soon.
Absolutely.
Awesome.
Thank you
Perfect.
so much.
Thank you.
Thank you.